Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question that I've chosen to go through here is 2015 Paper 2 Question 9 Part A. In this question we're told that Joan is playing golf, and Joan is 150 meters away from the center of a circular putting green. We're told that the radius of this circle is 15 meters, and they've marked in two tangents here. These two tangents, or this relatively triangular shape, represents the range of directions that Joan could hit the ball so that it would land on the green. And they've asked us to find the angle alpha, so they've asked us to find this angle. Now you should recognize that each of these lines are tangents, and they told me that the distance from here to here is 150 meters. By extension, the distance from the center of the green to where Joan is 150 meters. So I know that this distance is 150 meters. So the easiest way to do this question is to split it into two. Rather than taking the whole thing as one big shape, let's just take the right hand side of this shape. Let's just take this right angle triangle. I know that this side is 15 and this side is 150. Since it's a right angle triangle, I can use either sine, cos, or tan to find this angle, to find the angle here. So let's call this one, for the moment, let's call this the angle beta. Okay, so let's find the angle beta, and when we get that angle, we can multiply it by 2 to find the entire angle. So you should recognize that in a right angle triangle, if this is beta, then the 15 here represents the opposite, and the 150 is opposite the right angle, so it represents the hypotenuse. If you're dealing with opposite and hypotenuse, that means you're dealing with sine. So I can say that the sine of my angle, which is beta, is equal to the opposite over the hypotenuse. The sine of the angle is 15 over 150. So to get beta on its own, I can just say that beta is sine inverse of 15 over 150. Now, since we were asked for the question in degrees, just make sure your calculator is in degrees. I forgot my inverse there. So if I plug this in, sine inverse 15 over 150, if you plug that into your calculator, you'll get 5.739. So I know that this angle here is just 5.739. But that wasn't the question. The question was to find the whole thing. So obviously to find the whole angle, I need to multiply it by 2. So to find the original angle, which was called alpha, I multiply this by 2, and I'll get 11.478. Okay? The question also said to leave it to the nearest degree. So to round that off, to one decimal place. To round it to one decimal place, you get 11.5 degrees. So my final answer there is 11.5 degrees. Okay, so for part B of this question, we're given another triangle. Joan is at another hole, and we're given another scenario, but essentially it's just that we're given a non-right angle triangle. We've been given two sides and the angle in between them, and we've been asked to find the distance AH. Now you should recognize that if it's a non-right angle triangle, it's either the sine rule or the cosine rule. In order to find the distance AH, I'm going to have to use one of those. If I'm given two sides and the angle in between it, that means we're using the cosine rule. The cosine rule is that a squared equals b squared plus c squared minus 2bc cos a, where the capital A here represents an angle, and small a, small b, and small c represents the three sides of the triangle. So the only important thing here is that if you're dealing with the angle A, so this must be the angle A because this is the only angle I'm dealing with. If that's the angle A, then this must be the side A. That must be the small a. AH is my unknown. And then B and C can be 190 and 385, but they're interchangeable. So I just subbed in 190 for B, 385 for C, and 18 degrees for A. Then on the right hand side, when I plug in those values, I've got all numbers, so I can just plug it into my calculator, and I get a squared equals 45,185.43. Well, clearly I've no interest in a squared. I need to get the square root of both sides. So the side A works out as 212.568. But the question asked me to round it off, so I'm going to say that AH is 213 meters, and that's my final answer. In the third part of this question, we're told that Joan is hitting a golf ball from the point K, and the golf ball is going to land at the point B. And we're told that h equals minus 6t squared plus 22t plus 8 describes the flight of the ball. Now the question is to find the height of K. Okay, I know that h represents the height, t represents the time. What you need to recognize is that this point here represents just before Joan hits the ball, or the instant Joan hits the ball. At the instant that Joan hits the ball, that means that t is equal to 0. So to find the height at this point, we just need to sub in t equals 0 and find the corresponding h value. So if I sub in t equals 0, I'm just going to get h as minus 6 times 0 squared plus 22 times 0 plus 8. Now clearly 0 by any number is just 0, so I'm going to end up with h is equal to 8 meters. So the height of the ball, the height that Joan is hitting the ball from, is 8 meters. In C part 2 of this question, we're told that the horizontal speed of the ball from O to B is 38 meters per second to the minus 1. And we're asked to find the angle of elevation from K to B. In other words, we're asked to find this angle here, which I've labeled as A. So you should recognize that we're dealing with a right angle triangle. In the first part of the question, I worked out that this distance was 8, and I've been given some information about the horizontal, so I've been given some information about OB. If I know 8 and I know OB, that means I know the opposite and I know the adjacent, so I could just use tan to work out what the angle A is. So you need to recognize that ultimately I need to get the distance from O to B. And they've given me the speed. They've given me the speed from O to B, and I need to find the distance. So what should come into your mind here is your distance, speed, time triangle. If you want the distance, you need to know what the speed and the time is. So they've given me speed, which means realistically I need to find the time. So in other words, I need to find the time it takes for the ball to get from K to B. And luckily we have a quadratic equation to describe how the height changes relative to time. So if I know the height, I can work out what the time is. So you just need to realize that when the ball lands at B, that means that the height is equal to 0. At this point, the height is equal to 0. So if I know when the height is 0, I can work out the time it takes for the ball to get from the point K to the point B. So all I need to do here is sub in that h equals 0. And if I do that, I'm just left with a nice quadratic equation. Clearly I don't want to factorize this with a minus in front of my t squared, so I could just change all my signs, or you could view it as bringing everything to the left hand side. I get 6t squared minus 22t minus 8 equals 0. And to make life easy for myself here, I can just divide everything by 2, so I can factorize this as 3t squared minus 11t minus 4 equals 0. Now to factorize this one, I'll just continue on. I'll get 3t and t, I'll get plus 1 and minus 4. And if I was to continue this further and just solve it to find the two values of t for when the height is 0, I'll get 3t plus 1 equals 0, which means 3t equals minus 1, which means t is minus a third. And I'll also get t minus 4 equals 0, which means that t is equal to 4. So the two times in this graph where the height is going to be 0 is at minus 1/3 and at 4. Now if you visualize your minus 1/3, imagine it's just if you continue this one on this way. At minus 1/3 it would hit the ground as well. Obviously I'm concerned with this one, which is the time 4. T equals 4, that means it takes 4 seconds for the ball to get from K to B. So Joan hits the ball and 4 seconds later it lands at B. And that's really important for us, because if I now know the time it takes to get from O to B, and I also know the speed of the ball in meters per second, then that means I know my speed and I know my time. That means I can work out my distance. If you look at your distance, speed, time triangle, distance is speed, to work out the distance is just speed multiplied by time. So I can just say here that the distance from O to B is the speed, which is 38, multiplied by the time, which is 4. 38 meters per second multiplied by 4 seconds, that gives me 152 meters. So I know that the distance from O to B is 152 meters. And once we've worked that out, this is a very straightforward question. Because if you just look at your right angle triangle, KOB, I now know two sides, which means I can work out an angle. I'm looking for the angle A, which means that this is the opposite. And this is the adjacent. If you're dealing with the opposite and the adjacent, that means you're dealing with tan. So I can say that the tan of the angle, which is the tan of A, is equal to the opposite, which is 8, over the adjacent, which is 152. Now clearly to get A on its own, I'm just going to get tan inverse. So I can just plug this into my calculator. A is equal to tan inverse of 8 over 152. If I plug this into my calculator, I'll get A is equal to 3.01 degrees. And the question asked me to leave it to the nearest degree, So to the nearest degree, in this case, I can say that A is equal to 3 degrees, and that's my final answer. In part D of this question, we're given the following scenario. In this case, what should come into your head is that I'm just dealing with two right angle triangles. So I'm just dealing with sine, cos, and tan. They're right angle triangles. It's junior cert trigonometry. So in this case, the first part of the question tells me that tan inverse of a half is theta. Theta is equal to tan inverse of a half. That comes up a lot. It comes up a little bit more in coordinate geometry. I want you to recognize that usually when a question tells you that an angle is tan inverse of something else, you should bring the trig back across. So if theta is tan inverse of a half, you should view that as they're actually telling you that tan theta is equal to 1 over 2. That comes up a lot, usually more in coordinate geometry, and it will be in our first coordinate geometry test. So just make sure you're aware of that. Usually when a question gives to you in this scenario, you should actually view it as tan theta equals a half. You're just going backwards on what you would usually do. Now in this question, I've been asked to get D, the distance from G to D in terms of H, and the distance from C to D in terms of H. Now, I've actually already made this a lot easier because if you view your triangle GDE, clearly it's a right angle triangle. If I asked you to get the tan of that angle, well, tan is opposite over adjacent. So if you were just dealing with the triangle GDE, then you would tell me that the tan of theta, the tan of the angle is the opposite, which is H, over the adjacent, which is D. So notice I'm just after saying that tan theta equals a half, and now I'm saying that tan theta is H over D. Clearly that means that H over D is equal to a half. And I've been asked to get D in terms of H, so that just means I need to get D on its own. If you have two fractions and an equals in between them, you can cross multiply. So here I'll end up with 2 times H is equal to 1 times D. Or in other words, my first answer is just that D is equal to 2H. For the second one, you've just been asked to get the distance CD in terms of H. Well, I know that the entire distance from E to C is 25 meters, and I know the distance from D to E is H, which means clearly the distance from D to C is 25 minus H. So for CD, I can just put it in as 25 minus H. In the final part of this question, all I'm concerned with is the bottom half of that diagram, the right angle triangle GDC. In the first part, I worked out that GD is 2H and that DC is 25 minus H. And I know this distance is 25. So if you look at what we have here, we have a right angle triangle, and if I sub into Pythagoras' theorem, my only unknown is H, which means if I use Pythagoras' theorem, I'll be able to find H. So in this case, I can just sub in and say that 25 squared, the hypotenuse squared, is equal to 2H to be squared plus 25 minus H to be squared. I have one equation, one unknown, which means I can find my H. So 25 squared is 625. 2H by 2H is 4H squared. And if you multiply this out, you're going to get 625 minus 50H plus H squared. At this stage, you should recognize you have a H squared, you have a H, and you have a number. So more than likely, we have a quadratic. So you should probably bring everything to one side this time. So you get 0 equals 4H squared plus H squared. I have 625 minus 625, and then I've got a minus 50H. So obviously my 625s cancel, and I'm actually just left with 0 is equal to 5H squared minus 50H. So now I can just factorize, I can just take out my H. If I factorize this and take out, I can take out 5H. If you take out 5H, you'll be left with H minus 10. Now to solve this, the first one, I can say that 5H equals 0, which means H is 0, or I can say that H minus 10 equals 0, which means that H is equal to 10. So in this case, clearly it doesn't make sense to say that the distance H is 0, so I can cancel out my 0. My final answer is that H is 10 meters. So the height is 10 meters. Now, I hope this video made sense. If there's anything you're unclear on there, then again, just don't hesitate to email me or ask me in class, and I'll try and explain it differently.